So, hello. I hope you people will be healthy and energetic. In today's video sessions, I'm showing you a very important uh, robotic lesson. That is how I implemented the RPLidar A1, which is the radar which have ranges 12 meter, and I have implemented the RPLidar on ROS robotic operating system using Ubuntu OS, and I will show you how I use the Python script to record the RP lidar, the RP lidar data. So I have used that Python script. I will show you how can I use different Python script to record the data of the RP reader, and also to make some small decisions. This is the introduction, the introduction about the how we use Python script to get and record the data of RP reader. So I have made small decision on that RP reader data, and I will show you how can I implement the RP lidar A1, and I will use that scan data that is getting on the ROS. So first of all, I will show you how I implement it. First of all, in ROS, if you have know about the ROS, then definitely this video session will be very understandable to you. But if you are new to ROS, this video session is about a little bit advanced. So I started the ROS core first. After that, I have launched the ROS launch, the RP Lidar ROS, the RVs view. So I will show a little bit about that also. How can I use the, as I have one package RP Lidar, that is the package about for RP Lidar ROS. And here I have different folder and different launch files. There are different launch files for the RPLidar, and which actually, I'm launching this. Uh, Sorry, where is the that file? RPLidar A1. As I'm using RPLidar A1, so I will show you. Okay, actually, I'm launching this file, launch file, which is about the uh, which is the RVs. Sorry. Okay, so this is the launch file. I will launch these files. As I have launched these files, and I have got the RVs view of the radar. As I'm already the lidar, RP lidar is running on my RVs. And as you can see, yeah, fact, I'm the obstacle detection. After that, I will show you how to scan the data. This is the topic. The RP Lidar actually publish the data on that topic, and the ROS get the data using the ROS score. So again, I will show you a little bit to have some idea about that. Subscriber. Okay, ROS topic. Echo scan. So that's how the scan data is coming on from the RP lidar scanning, laser scan. And we get different, distant ranges of array, and we have the intensity. So basically, I will show the Python file, how we record the the data from the RPLidar, and how we make small decision, or you can go for the advanced decisions. But I will show you a little bit about the small decision, how we make the small decision on that RP, the lidar scan data. I will show you the simple uh, Python files. Actually, we have import the ROS and we have the from laser scan, which is the module in Python for the laser, such as RP lidars and other lidar scanning. And we have the sensor messages, as we have Python have built in modules and instances for the sensors, which we call the sensor messages. And from the sensor message, we have defined one callback function, and actually we will, the length, it will be print the length of the ranges, total ranges. Um, After that, I want to calculate the field of view. To print the field of view, for that I will have first, store the value of minimum angle in that range, and then we have used the variable for maximum angle in that range. And after that, I have just calculate the print calculate the field of view, and also it we get the length of that ranges. Actually, ranges in array where different ranges we get, the value of that inside array, we get at different indexes, we get a different ranges value. Actually, there are, in ranges inside, they have a lot of different angles positions of that lidar, as RP lidar is rotating in 360-degree. So in one range scanning, how much it get with in the data. So I will show you that. As I have named the file, as I have named this file scan 4.py. So I'm actually ROS run the RP lidar, the package, and that Python file. So it printed out on the, we get the field of view, which is in radian, as we have seen in radian. And also that's the length of that ranges of array, which is 760 angles we get in one scan. And I will show the other Python files, what they're doing. Uh, Again, I have, calculated, actually in the ranges of that array, we have different angles, and corresponding of that angles, we have different distance value. So I have just calculated the distance at 0 degree, distance and what one at 120 degree, and distance at 240 degree. After that, that Python act as a subscriber, and it subscribed to the topic scan, as the lidar printed the publish the their values, their data on the scan topic. So we Python has subscribed to that data, and we get that data as we have mentioned in that file. So that file name is scan2.py Python. So I will run ROS run the package and that file, and we will show it will show us. So as we have seen that a distance at 0 degree, okay, sorry, as I commented, the printed is okay. Okay, print at zero value, 0 degree. Okay, I save again it as it was modified before. As we have defines and as we have made the decision that distance at 0 degree, that is given distance at 120 at 120 degree, that is 0 point something, lot of values after zero distance at 240 degree. So I will show another files that is scan to file. So in this file I make a small decisions in these Python files. This Python is file is same like a previous file, but I have made a little bit this decision on that file, and the data we get before in scan2 files as was this was the scan2 data we get. And now I have made a small distance, a small decision on that file and that data. That is, when I get the distance at that particular degree of angle, I have multiplied that distance by 2. Okay, so we will ROS run that scan3 Python file that acts as a subscriber. Now also it acts as a publisher if you want to publish the uh, that value. We use also modify, the modify scan values. So I will show that also. Yeah. So that is the value that is at that particular degree of angle, and it is multiplied by 2, and we get double of that we have get before in, as we have seen, as we consider only to confirm it, as it we get the double of value as we multiply by 2. So as distance at 0 degree is 0 point something 4390. The same way as we multiplied in Python and scan3 Python file by 2, at that distance was multiplied by 2, so we get 0.87800 as it was multiplied by 2. The same way before we get at 120 degree, that was 0.1319, and at 120 degree we get something like that. At 240 degree we get these before, and after multiply by 2 we get 0.9580. So as this video session was about how can we use the RP lidar, the lidar, and how we publish the scan, the lidar 360-degree uh, obstacle distance, and also show you how to implement that lidar on ROS And also I have shown you how we can use the Python subscriber to record the values of that scan data, and also how to make small decision. In the future you can make a big decision on that data. You can use for it for machine learning, for robotic autonomous vehicles, and other it has a lot of applications. So this was the short sessions about that ROS, the Lidar scanning. And in future, I will show you more interesting videos about that, the ROS and robotics related concepts. And also we will go for machine learning and AI side to have a broad view of robotic, and how can we use the robotic for our daily life applications and to make our life more comfortable and more autonomous. Thank you.